extensively working on conflate meteorological data with power
Yes.
and anticipate where I'm going to need to have
Yes.
teams. That's very good.
Yes, and it's operational. So the reason why we have this system now is because 9 years ago there was a massive blackout on the East Coast, and nobody could tell the Secretary of Energy if 1 million people or 15 million people were out of power. So it's about people, the 78 customers, and about how we go about doing our things. So we go from one building to another, we wake up in the morning in our homes, and then we go to work, which is another building, we use the transportation network. So it's all about us. ORNL has been working on this population aspect for a long time now, and we have at 90 meter resolution, daytime and nighttime population distributions for the whole country, for the whole world actually, but at 90 meters for the United States. I'm going to rush a little bit. And so this has been used for identifying settlements. So what you're seeing is in Nigeria, where we have used machine learning to identify where people are, or in other words, identify where the settlements are. We have done this for Ethiopia also, and this is through the Gates Foundation. We just assume when we're hungry. Like last night, I was Googling for food, and I got here in Orlando at 10 o'clock, and almost nothing was open in the downtown. We just assume that, but that information doesn't exist for large parts of the world. We have funding from the Gates Foundation to identify where settlements are, where humans are, and what the demographics look like. Not for finding a Wendy's, but their mission is polio and malaria eradication. They have 3 pillars: polio, malaria, and then other diseases. We've been using GPUs, and we are beginning to use deep learning for this.
Just to add, this is Voodoo's work, right?
Yes.
Yeah. The reason this came about in part is because whenever the Gates Foundation and others mobilized in country, the national data overestimated
Yes.
populations
The census is horrendous there.
consistently, so they spoiled medical supplies and wasted resources in responding, and this is actually allowing them to get much more surgical.
Yes. So,
Really amazing work.
So censuses, well, we couldn't trust the census, so surveys were administered in a very controlled way, and then we figured out how to extrapolate those censuses for the whole country. That's what we have done.
Sir, can you explain what your graphic is showing us, please?
So this was essentially the red that you see here is after the machine learning, just the settlements that have been identified.
So building footprints.
Yes. So the settlements and building footprints both have been done, and this is in some sense a real-time track of the 3 colors you see here. Red is for large complexes, blue is commercial buildings, and green is residential. And you'll see it's going over a residential area now. So this is the square that's being processed, and then it switches as it goes into a more commercial area. And then this is going to again turn into an illustration of the large buildings when it gets to them. So all this is dynamic on the GPU real time. What we are wanting to do now is to be able to process a whole country at a time, and so burst into some of our high performance computing systems like Titan and say, I want to do this for Sudan. And a few hours later, hopefully have the results. We're not there yet, but we're trying to get there. So under the hood, this is how it looks like. So we have digital globe and other imagery that comes to our cloud. Auto rectification sometimes happens. And then we have a mix of GPFS and PanaSAS file systems. The GPUs and the training happens in a bunch of GPU-enabled machines. And then once the model is available, it basically runs on an institutional cluster here. At the end of it, some analysts look at it, and if occasionally edits are required, they're made. We have had a lot of issues because we started with about 200 terabytes of data, and now we're in the petabyte scale, and this has been weak. So just before coming here yesterday, I had a meeting with some of the higher powers at the lab. We're now getting, this whole thing here is now being replaced with a Lustre high performance 1.5 petabyte file system. So all of the bottlenecks that we see here will potentially get eliminated. Also the staging of all the different things that are going on become a whole lot easier. The other thing that we've been working on is attributes across the world. So Robert Stewart has been leading this World Spatio-Temporal Analytics Mapping project for the National Geospatial Intelligence Agency. And this is pretty intense. 30 major data sources, 14,000 plus attributes at different levels of completion for all the different countries. It has resulted in about 16 million records right now, covers 50 years, and over 200 nations. And the NGA is interested in this. This is how it looks like, where you have a temporal selector, and then you can select which countries you want, and it shows all those different attributes. Now, on top of that, what we can do now are different kinds of analytics. Oh, this looks horrible. But essentially what this shows on my laptop here are, so basically I have a tree here which shows how Yugoslavia broke up into all these different things, different countries. And along with this spatio-temporal aspect, where with each of these countries there are about 14,000 attributes. So we were looking at percentage of population that's part of the military now. And so we see some interesting trends. I looked at some other countries in the upper, in the Scandinavian areas, and there's some very interesting trends of their economies and fish production. So very interesting observations can be seen from this. There's also, this example is here about aid to West Africa and how those countries have used that aid. This is for sanitation. I really shouldn't have broadcast, nothing is readable. This is about how those different countries and how they've used, how the trends are, how they cluster together, how they have spent the money. And then summary statistics on all the different countries and their effectiveness. This is just illustrative of the power of a tool like this. And what's amazing is that all of this is interactive. It's literally, you can go there and select and interactive. Different kinds of clustering is done, and so you see these spark lines below. These spark lines basically do something called, essentially it stretches time to see how trends match or how similar or how different they are. So it's, I forget the exact term what it was. But that's being done here to see how these signatures look like. And if there are local anomalies, if the neighboring countries are doing things differently. Similarly, there's high dimensional pattern matching attributes. So this on my laptop here looks like a lot of lines, completely washed out here. Portfolio analysis of, say, all these different attributes across these countries. So if you were to cluster them hierarchically, what do they look like? And then you can see which countries have similar attributes or organize themselves hierarchically in some sense when it comes to these different attributes. Under the hood, we've got HTML5, which is the front end, D3. Everything is a RESTful web service, but what we are working towards, and we've been working on this for a while now, is to provide data as a service and also analytics as a service. And so we've got R and different versions of, we've modified some portions of R to do time warping and things like that. We have done significant improvements in a number of the statistical packages to improve their speed and efficiency, and we are right now working on putting it back in the R, to the R community. So fundamentally, we have a database, a RESTful interface, and attributes, and analytics as a service. So when I look at this, what I've been talking about so far, there's a few fundamental things that emerge. So as we talk about big data and how all this is changing our world around us, second last.
Cool.
There's the system software and the middleware services, or in other words, the haystack, which is very important. And for that, the fundamental thing that we need to understand is what is the problem. We have a hammer in need of a problem. So fundamentally, we always ask the question, what is it that we need to accomplish? So there's different levels of hardware and software and configuration of those that we need to figure out. And this is always moving. Like our projects over time have gone from just one country, processing one country for settlement mapping, and it took us about a year and a half to do that. And now we are wanting to do tens of countries in a year, to burst out into big machines and do it. It's shifting. And so naturally, we have to come up with an architecture that plans ahead a little bit, but has enough flexibility where we can adjust it. Data services, the analytical services, they are very close to each other. And as we do this, there's aspects of provenance and indexing and metadata discovery that becomes very important. In analytical services, there's a ton of deep learning and machine learning algorithms that can be unleashed on this data. And we have to be careful as to understand what the data is. Just like in statistics, the core assumptions have to be met. We should think of analyzing data in a similar fashion where we just don't unleash any algorithm on a data and say, wow, here's something awesome I found. So it goes back to the veracity of the data. And as this matures, in Oak Ridge, we have gotten into where we're needing workflows of things. So this is where the scale comes in. A little bit ago, we were talking about privacy, and privacy is always going to be a challenge as this evolves. In our space, in Oak Ridge space, in our GIST space, we've been working on land use, on population dynamics, on when special events happen, when things happen, proactive responses, critical aspect. Infrastructure is a core focus for us. And then citizen science. We have a project that has just gotten off the ground called PlanetSense, and that is to create this data source of volunteer geographic information. As is, social information is lacking in geolocation. So whatever that we can find that is geolocated, can we create data sets that are usable, somewhat like the WorldStamp project that I illustrated a little bit ago. So that's something that has gotten off the ground recently. And then urban. Urban is a very dynamic place. We have sub-second level processes, which are electric grid and such. We have periodic hourly level processes. We humans fall in that. We do things in a certain temporal frequency. And then there are things that are decadal. Buildings are built to last at least 30, 40 years in the United States. Other parts of the world, buildings stand for 300 years. And then there's aspects of policy here. So as scientists, I feel we have an obligation to do the right science to inform policy down the road. That's all I have.
Thank you.
There are already a few questions, but certainly some time for some more questions, discussion. Dan?
So thank you very much. It was a great presentation.
Thank you.
I feel like the labs have all of these responsibilities that they fulfill. They solve hard projects, they inform policy, and you talked a little bit about those. Is there contributions you're making back to the data science or big data community that we can leverage? I mean, a lot of what you're showing are things that only work because they run at the lab. So how are those translating into other environments or providing capabilities to the rest of us that don't have a lab?
So a very large part of our portfolio is open science. And so everything that we do is, almost everything we do that is sponsored by your and my taxpayers' money. So it's out available in the open. So anything that results in a publication and anything that results in a software release is available to the public for about 90% of the cases free of cost. So that's one way. We occasionally, when it's something significant, put out a press release so that the community adoption, the awareness and the community adoption is a little bit more. But recently we have become part of NASA's Whirlwind development team, and so now as we work on this and several other projects where Whirlwind becomes our primary geospatial interface, we're contributing back to Whirlwind. The RServe and the R stuff that I showed a little bit ago on WorldStamp, all that is again going back to the community. George Ostrokov leads I shouldn't call it a center, it's more like a group, Parallel Big Data R, and that is about using R at scale. And so they've gotten it to run on 60,000 cores, and that code is available out there. Mm-hmm. So the way we go about it is we think of the publication as the middle point, where we tell everybody, look, this is available. We always deliver products at the end. Usually these products are at the national scale, things that all of us care about. The buildings and the sensors work that I showed, industry cares about it a lot. We have industrial partners, and so they take those algorithms and run with it. So it's a landscape really of where we are working with industry, we're providing things to the community, and so forth.
Okay, you just mentioned that y'all are working with Whirlwind a lot now for your
Yes.
open interface.
And use the mic so people in the webinar can hear.
Okay. You just mentioned that you were using Whirlwind a lot of your geospatial interface, but a lot of what you presented just now indicated you were doing web-driven development. Now, maybe I'm a little bit out of touch with this. Last time I used Whirlwind, it was a lot more thick client-driven, required native code. Is that changed with Whirlwind
So
over
there's
time?
Whirlwind Web now, which is pretty nice. It's like Google Earth went web, almost exactly like that. Whirlwind went web. The examples I showed here are all based off of, in fact, Eagle Eye is based off of Adobe Flex, and we are working on an open source stack now for the front end. So it will be a mix of open layers potentially. We haven't quite finalized it, but potentially open layers, JavaScript frameworks, more responsive codes. But we have an Energy Water Nexus project that's coming online, and it's about energy water. The way I see it is that Nexus really